Right, example 3, cadmium has a work function of 4.22 electron volt. So we have to calculate the threshold frequency, the maximum speed of the photoelectrons when it is shined by a UV radiation with wavelength of 275 nanometer, as well as the stopping potential. Right, so we know that the work function is given as 4.22 electron volts. So we need to convert this into joule first. So times it with this value. So it should be equal to 6.75 10 negative 19 joule. Okay, so you can only solve the question in joule, not in electron volt. So now we are going to use the equation, this equation. So from here, you will get the threshold frequency to be equal to 1.02 times 10 to the power 15 hertz. Okay? Okay, and then question B, we have to calculate the maximum speed. So we know that the only thing that relates to speed in this subtopic is the kinetic energy, which is equal to half m v max square. Okay, so how do we get this is by using the Einstein photoelectric equation, which is equal to E k max plus W naught. Okay, so if you simplify this, if you further expand this equation, you get hc over lambda half m v max square plus dengan the work function. So from here, we can then rearrange to get the maximum speed. So you should get 3.26 times 10 to the power 5 meter per second. Okay, and then last question, the stopping potential is just given by the kinetic energy, where the kinetic energy is gonna be equal to stopping potential equal to half m v max square lah. Okay, so what I did is basically changing this to EVS lah, another equation untuk kinetic energy. Okay, so you will then get the stopping potential to be equal to 1.5 mana satu? 0.303 volt. Okay, so that is the solution for example number 3.